Hi, welcome to our second week of Environmental Biology Online. Last week we got to read the first half of the Heinrich book, and overall it seems like the class enjoyed that very much. Now this week we're going to get into some material that's a little bit more serious. We're going to be looking at the process of science and how to do graphing. These topics may feel a little bit more overwhelming, a little bit more scary to you, and maybe not as interesting, but they're the absolute foundation of science. And this is a science class, so you need to know how science works and you need to know how to do some graphing. So this week I have the content split up into two big pieces. One half is the process of science and the other half is graphing. So first you'll engage with the process of science, and to do that there's a whole number of resources in which to look at. So you'll open the folder that says the process of science, and in there are a whole bunch of things. So one of the things that I definitely recommend you spend some time with is the Understanding Science website. It's a huge website, there's tons of information, I couldn't possibly assign it all to you in 1 week, but I've highlighted a couple of sections that I think would be particularly useful for you. So look at those. And from there, I also got this process of science diagram, which is the banner for our week. And you can download that as an image. And there's another version that's got a lot more detail, so you can really see how the process of science works. Okay, just remember that the scientific process includes making observations, asking questions, coming up with hypotheses, making a test for that hypothesis, and then coming to a conclusion to decide if that test supports your hypothesis or not. And then continuing to ask more questions,
making observations, asking questions, coming up with hypotheses, making a test for that hypothesis, and then coming to a conclusion to decide if that test supports your hypothesis or not.
And then continuing to
making observations, asking questions, coming up with hypotheses, making a test for that hypothesis, and then coming to a conclusion to decide if that test supports your hypothesis or not.
I've also created a couple of documents for you. One just sort of outlines how a scientific paper is written. So it's like a one-page document that explains what happens in each section of a scientific paper, the introduction, the methods, the results, and the discussion. And then there's another one in there that talks about how to go through the scientific process yourself, like how to design an experiment. So that's going to be useful to you as you design your own experiments later in the semester. So I recommend looking at that and printing it out. So once you've done some background reading on the process of science, there's a few ways to actually kind of use that information and apply it to show me that you understand it. So the first way is to take a quiz. There's a process of science quiz. And when you take that quiz, you should be able to get immediate feedback after every question, which will tell you the answer, or it will tell you if your answer is right or not. It won't give you the answer. And it might also give you a little bit more feedback to help you understand what the correct answer is. And you can take that quiz twice. So after you take the quiz the first time, if you wait an hour, you can take the quiz a second time. So that will give you time to review the information, and the hour break will help me see that you are learning it rather than just memorizing it, hopefully. So the other thing you can do is engage in the discussion. This discussion is totally different. This time I'm giving you a scenario of a situation that happened to a real scientist and asking you to hypothesize about what the reason for this scenario could be. So follow the directions in the discussion, and this is a place where you can practice writing a good hypothesis. So figure out what a good hypothesis includes and how to write a good experiment. So use those aspects of good experimentation. And it's also a place to just ask any questions you have about how the scientific process works. And there were some examples of that in our first discussion, some questions people asked, and I think it was a really rich place for learning. Okay, the third and really big thing you'll do to engage with the process of science is to do the lab. So the lab has two parts, and the first part is just about the process of science, and what you're going to do is choose one of the articles that I've selected for you. So I've selected some articles that I think will be fairly accessible and also have like the elements that I want you to look at. So choose one of those articles, and I want you to read it as best you can. I recommend starting with the abstract. And the abstract is usually just one paragraph. It's the very first part of the scientific paper, and it summarizes the whole thing. So it explains the purpose, it summarizes the results, and gives the conclusion of the paper. So read that carefully, maybe one sentence at a time. What does this sentence mean? Read the next sentence. What does that sentence mean? And you might read it 3 or 4 or 5 times until you understand it. So the abstract is super important. And then go through and read as much of the paper as you can. The introduction is usually pretty followable, so I'd read that. The methods and the results can be pretty tricky. So just do your very best. And then again, focus on the conclusion. The conclusion or discussion can be labeled differently, is also a really important part of the paper. So don't get frustrated if it's too hard. Just notice. Just notice, oh, this is what's hard for me, or I'm really struggling here, and move past that. So you'll read the article to your best ability, and what you're going to turn in is a review of the article, and you'll highlight a couple of certain aspects of the scientific process in that review, and it's all written up for you what to turn in the lab guide. So you'll have to download the lab guide and read it really carefully, and then you'll turn in your article summary as a document that you'll upload to Moodle, and I'll get it there through the gradebook. Okay, so that's the process of science. The second big chunk of our work this week is working with graphing, and there's fewer resources for graphing. So you'll open the folder that says graphing resources or something like that, and inside are 2 things. And the first thing to look at is a guide to tables and graphs. And in this, it tells you all the different kinds of graphs there are, bar graphs, pie charts, line graphs, explains when to use them all, gives lots of examples of what those kinds of graphs look like, how to write about them. It also describes tables, what the difference is between a table and graph, how to write about those. So I recommend downloading that, printing it, and keeping it nearby, because you'll need that for graphing throughout the semester. And then the other document in there is a PowerPoint presentation, or if you don't have PowerPoint, it's a PDF. And this one gives the titles of various graphs and asks you to guess what kind of a graph is this. So given this title, what kind of a graph would you expect it to be? Can you sketch it out? Can you draw the axes and have a sense of what that graph will look like? If you can do that, then you have a really good understanding of how graphing works, and you're all set. So I definitely recommend trying that out. Once you've read the background information, then you can take a quiz on graphing, and it's a very short quiz. It's about having you see if you can interpret patterns in graphs. And then the last thing you'll do is the second half of the lab, which is about graphing. And this time you'll take that same scientific article that you read the first time, and this time you'll just look at the graphs, the figures, and the tables, and answer some very basic questions about those. They're not intended to be tricky. They're intended just to draw your attention to the different elements of the figures and the different elements of the tables. So just answer them as plainly and straightforwardly as you possibly can. And then the second part of the lab, which should be more challenging, is to actually create graphs. So I have some data there for you to create graphs from. So the challenge, first of all, is to decide what kind of a graph is this. Should this be a pie chart, a line graph, a bar graph? And then the next thing is to set it up, make sure you label the axes appropriately. Which is the independent variable? Which is the dependent variable? Remember, the independent variable always goes on the x-axis. The dependent variable always goes on the y-axis. And then try to come up with a really good caption for your graph. That's also challenging. The caption should always include information from both axes. It should say the independent and dependent variable in the caption of the graph. So do your best to create those graphs, and feel free to contact me if you need any help at all. If you've never done graphing before, please try to use the Create a Graph website that I found for you. It's a really simple way of creating graphs, but it will take some time to learn. So you do have to go through, click on all the buttons, see what they do, try to figure out how the program works. So you're going to have to train yourself. It will take some time to figure it out, but will take far less time than using something like Excel. So feel free to use any graphing program you want to. But Create a Graph, I found, works really, really well. When you're done creating a graph and Create a Graph, I recommend doing 2 things. 1, save it as a JPEG, and 2, email it to yourself. If you email it to yourself, what Create a Graph will do is it'll give you a link to the graph, and then you can click on that link and go back and edit the graph if you need to make a revision for, a later version of your paper, or if you want to revise for more points. So that's a really good thing to do. Okay, so that's part 2, graphing. The last thing you might do this week is to start doing your home base. So your home base is about asking questions, the second home base, and it's about trying to use that scientific process and the method of engaging with nature that Heinrich has demonstrated so well. So you're going to make observations, you're going to ask some questions, you're going to create some hypotheses about those questions, and then make further observations to see if you can come up with any answers to those questions. So there's no right answers, you have no need to be right or correct, it's just a thinking process, and in that vein, there's no need to do any research at all. So please don't be looking up information in order to find the answers to your questions. I'd rather you think about them and try to figure it out. Okay, you're going to do great this week. Please stay in touch if you need anything at all. I love hearing from my students, and I'll see you online.